Welcome to the video presentation on earthing or grounding. As we all know, earthing is the most important aspect of power system for safety of people and protection of network. Thus, always ensure that earthing to systems, equipment and lines is maintained well. There are two types of earthing. They are plate earthing and pipe earthing. Let us look at the step-by-step execution of plate earthing. For the work execution of plate earthing, make a bore of size 60 by 60 centimeters on the ground of 1.5 to 3 meters depth. Then, place an earth plate of size 60 by 60 centimeter and thickness of 3.18 mm duly connected with nut bolt and earth wire vertically. This plate is covered with layers of 15 centimeter charcoal and salt. Then, the earth wire is concealed inside a GI pipe of 12 millimeters and taken up vertically to the ground level. The 10 mm GI pipe is fitted over the pipe with funnel at the upper portion for pouring water into the pit. A masonry cement concrete box is prepared with a cast iron cover in case of heavy load on the system. You can use plates of 90 by 90 centimeters instead of 60 by 60 centimeter plate. Let us look at the step-by-step execution of pipe earthing. Dig a bore of 4.75 meters depth of size 60 by 60 centimeters on the ground. A 2 meter long GI pipe of diameter 38 mm and perforated with holes of 12 mm with a tapered edge at the bottom is laid vertically. Then water is poured in the GI pipe to be absorbed in the soil through the perforation. A fine layer of charcoal and salt is filled around the pipe. Then a 19 mm GI pipe is fitted through a reducing socket. The earth wire connection is made at the bottom of the perforated pipe through cable socket. It is taken inside from the pipe and brought out at the upper portion through the funnel. The funnel is kept 5 to 10 centimeters above ground level. A masonry cement concrete box is prepared with a cast iron covering. A typical arrangement of earthing the equipment and structure of the distribution substation of 11 kV by 433 to 250 volts with AB switch and horn gap fuses is shown as per REC construction standard F2. As shown in the figure, the earth pits should be located as per REC construction standard F5. One of the earth electrodes on either side of a double pole structure should be connected with one direct connection from LT lightning arresters, if provided, and one direct connection from lightning arrestor on HT side of 11 kV. Each of the remaining two earth electrodes, 3 separate connections have to be made. They are one from neutral, the other from transformer body, and the last connection is from the earthing terminals of the poles. A typical arrangement of earthing the equipment and structure of the distribution substation is shown as per REC construction standard F10. A 40 mm GI wire should be used as earth lead. No jointing should be done in an earth wire. The transformer neutral earth pit should be independent just opposite the LA earth pit. Adequate quantity of charcoal and salt should be used to keep the earth moist. Water should be poured into the dump to keep the surrounding soil wet. In dry rocky areas, black cotton soil should be filled in the earth pit. The value of the combined earth resistance should not be more than 2 ohms. This is the earthing pit. It has two connections. One is connected from the neutral and another is connected from the transformer body. Both the connections are different. The transformer is connected to 3 earthing pits. This is one of the pits. When you see inside the pit, there is a bore inside every earthing pit. It is deep enough to reach the water level for natural earthing and up to the moisture level for artificial earthing. The electrode you are seeing is 3 meters in length. A 40 mm diameter GI pipe is used in place of earthing electrode. Now, the lineman will show how to place this earthing electrode inside the bore. This electrode is going inside the bore. Then we will remove the electrode to see the depth. When we remove the earthing electrode out from the bore, you can see that the earthing electrode is wet at the end. This shows that the electrode has reached the water level. Now put the earthing electrode inside the bore again. Let us see the earth electrode connected to earth lead. Now I will test the resistance of the earthing. Let us now see the tools required for earth resistance testing. These are the spikes and this is the digital earth resistance tester. I will show how to connect it. You can see its terminals here. At the back of the tester, the connection diagrams are shown. This is a 15-meter lead wire. This is a 30-meter lead wire, which are connected to the spikes. This is used for earthing terminal. Let us now see how to fix the earth spike. Here, the first spike is being kept 30 meters away. This is the 30-meter lead wire. This is the other spike, which is being kept 15 meters away. Both these lead wires are connected to the testing instrument called earth tester. You can see that two wires are connected to the digital earth resistance meter. The 15-meter lead wire is connected to one spike and the other 30-meter lead wire is connected to the other spike. This third wire is under test, which can measure the earth resistance. It is connected to the earthing electrode. Let us now see how to know the actual value of using digital earth resistance tester. First, switch on the tester. Then press the test button. The actual value is displayed on the screen. It is 0.16 or 0.17, which is less than 1 ohm. As the actual value is less than 1 ohm, this test can be considered positive. This is an electrode which has a layer of salt and coal around it to maintain moisture level. During summer, the level of water decreases. To maintain the moisture level, you must pour some water once in a month. The bodies of all equipment in electrical installation, namely switch gears, transformer, metering cubicles and so on, are always connected to double earth. There is separate earth connection for lightning arrestor LA and transformer neutral. You can see here that there are 3 lightning arresters on the line. They are connected to the main line. The lightning arresters absorb the extra charge into the earth in case of lightning and save the equipment. You can see here that the 3 lightning arresters are connected with the earthing terminal. Now, I will tell you about earthing of transformer mounted on a double pole or DP structure. You can see here that a transformer of 315 kVA is fixed on the DP. It has 5 earthing connections. One earthing is connected to the body and the second earthing connected with the body of the transformer. Here, you can see the double earthing connected to the neutral. The body earthing goes into one earthing pit. The earth connected to neutral goes into the second earthing pit. The earth connected to lightning arrestor goes into another earthing pit. Thus, every pole-mounted transformer in DP structure is connected to 3 different earthing pits. Maintenance and improvement of earth resistance. There are 4 ways to improve earth resistance: by increasing the depth of electrode, by increasing the size of electrode, by increasing the number of electrodes, salt treatment. What should we do if the earth resistance is too high? Dig a 1 meter deep pit near the electrode and fill it up with saline water. The ground will absorb the water, remain in contact with the electrode. In this video presentation, we have seen how earthing is done and how to use the digital earth resistance tester to measure earth resistance.